Hey everybody, let's talk about sinusoidal function transformation. So remember, sinusoidal functions are some sort of transformation of the sine function. We know we've got a couple of different ways we can show those transformations. Here we're starting to talk about what these types of transformations do to both sine and cosine. So let's get into it. Amplitude, remember that's our absolute value of that A, which is half the difference between the maximum and the minimum values. We also know the midline, which has been typically y equals 0. But if we have a vertical shift, which we see here and here, those are those vertical shifts, that tells me that that y equals 0 is going to add by d. So that's going to be y equals whatever that d value is. For the period, we've talked about this before, that's full cycle, which typically with sine and cosine is 2 pi. But if it changes by whatever these horizontal compression or stretches are, we're going to divide it by that b value. Remember, because in Funky Town, everything is a reciprocal or the opposite of what it seems. And we also know that frequency is still the reciprocal of the period. So we'll say that that's b over 2 pi. So let's kind of start talking about some of how we can apply what we know to these graphs. So if I look here, this tells me that's A, that means that the amplitude is also 3. This here tells me this B value is 2. So remember, the period is going to be 2 pi divided by B, which is 2 pi over 2, which reduces to 1 pi. We also know here there's nothing behind it, so we could add a plus 0. Therefore, my midline is also y equals 0. I can draw it in right here. There's my midline. And from 0, my max value was going to be that midline plus 3, so that's a maximum value of 3. My minimum value was going to be that midline of 0 minus the 3, so that's negative 3. And the frequency is just going to be 1 over the period, which is pi. So let's start by, I'm going to just kind of sketch out my amplitude. So if this is 1, 2, 3, this is going to be my maximum boundary, and here's negative 1, negative 2, negative 3. Here's going to be my minimum boundary. I'm just going to sketch up here just to remind my brain, what does sine look like? Sine looks like this, remember, where we usually have a peak at 1 and a period of 2 pi. So if I remember what that looks like in the context of how my graph is changing with an amplitude of 3, a period of pi, that means here at pi, I'm not going to see half of the cycle. I'm going to see the full cycle. So just like sine, we're going to start on our midline at 0. And then if I know I'm breaking up this period into essentially five critical numbers. So whatever's happening at the start, a quarter of the way to the period, a half of the way to the period, three quarters of the way to the period, and then the full period. So that tells me if we're talking about sine, we're going to go up to its maximum. So this is a quarter of the way up here, which is typically pi over 2. But because we're doing that in half the horizontal distance, remember, because if this b is 2, that's also that horizontal compression by a factor of 1 over 2. So everything is happening horizontally in half the distance. So we're going to go up to the peak. At pi over 2 will be the 0 again, down to the valley, 3 quarters of the way, and then back to 0 in a period of pi. So because that period is pi, again, we're going to see that full cycle of sine within 1 pi, where we go, here's our midline, we go up to 3 and then down to 3. So then we're going to continue this pattern to the right, and then we're going to continue it also to the left. Okay, and if I want to really look at this, knowing that the period is pi, we can see from here to here is 1 full cycle of pi, but we also know if b, we said was 2, this tells me there are 2 full cycles within a normal 2 pi. And so if I look at that, here's a normal 2 pi, I can see it happens 1, 2 full times. That tells me that a b is 2, that in a typical sine wave, we actually have 2 full circles of it. All right, let's look at this one. It says Okay, so this is our amplitudes. Remember, the amplitude's the absolute value, which is 2. And here I can put a 0 behind it. So my midline is y equals 0. I know it didn't shift up or down. Here I can rewrite this as, instead of x over 2, I can rewrite this as 1/2 x. That tells me my b is 1/2. So if the period is 2 pi over b, that's going to be 2 pi over 1/2. Dividing by a fraction is like multiplying by its reciprocal, and we get 4 pi is the period. And of course, the frequency is the reciprocal of that. Our max value is going to be the midline plus the amplitude, so that's 2. And then the minimum is going to be the midline minus the amplitude, so that's -2. So if I look here, my midline's at 0. And my maximum will be at 2, and my minimum will be at 2. This is just giving me a boundary so that I don't draw my functions or my graphs outside of my boundaries. The other thing here is I have to remember the period is 4 pi, which typically it's 2 pi. So if cosine typically looks like this, okay, this is a typical cosine where we start at the maximum value and it ends at 2 pi. Keep in mind there's a couple things going on here. Number one, we see there's a negative here. So remember that negative tells me it's a vertical flip over the x-axis. So instead of starting at the peak, we're going to be starting down here at the valley. And instead of ending at 2 pi, we actually are going to see it ending at 4 pi. So within 2 pi here, we're only going to see half of that graph. So remember, half of the graph would look just like this downward part of my graph. So let's start to graph that. So at the start, instead of starting at my maximum, because we're having a vertical flip of -2, we're going to start at the bottom. And then instead of going up to your 0, typically at pi over 2, it's doubling that horizontal length. So instead of happening at pi over 2 here, we're going double that to pi. And then again, at the peak, will be at 2 pi. So that's half a graph within 2 pi, which means if I follow this pattern backwards, we're going to see one full graph. So this full graph and a total of 4 pi on the horizontal. And we see that because here's our 4 pi period. And our frequency, our b value is, we said it was 1/2, which means within 2 pi, I only see half of the graph. All right, let's turn the page. All right, let's look at sine 2 sine x over 2 plus 1. So first of all, our amplitude is 2. Okay, our midline we see here is y equals 1. So keep in mind that shifts everything up 1. Here I see x over 2 can be written as 1/2 x. Therefore, I know b is 1/2. Okay, so the period, if that's 2 pi over b, that's 2 pi divided by 1/2. Remember from before, 2 pi divided by 1/2 is multiplying by the reciprocal of 2, which is 4 pi. And their frequency will be 1 over 4 pi. Now keep in mind the minimum value or the maximum value is going to be your midline plus the amplitude, which is 3. And then your minimum value is going to be your midline minus your amplitude. So it's going to be -1. So let's kind of sketch out what this is going to look like here. So number one, our midline's at y equals 1. So it's no longer on the x-axis. Here's my midline. My maximum value at 3, I'm going to put up here. Here's 3. And my minimum value at -1 is, whoops, go back, at -1. So this is going to be the boundary of where my graph is. Remember that if my period is now at 4 pi, I'm only going to see half the cycle within 2 pi. So remember, sine typically looks like this, right? So we're starting on the midline, going up to the peak a quarter of the way, halfway we'll be back at 0, 3/4 of the way we'll be down at the bottom, and then finishing a full cycle at 0. Well, my midline here is now not out in the x-axis anymore, but it's at 1. And then going up to the peak will now not be half of pi, but a quarter of 4 pi, which is just pi. And then from there, this is what half of our graph will look like within 2 pi. If I continue that pattern backwards, we see it like this. So here we see we've got a full pattern within 4 pi, and within 2 pi, we'll only see half of our graph. So that's where we get b is 1/2. All right, this last one for number 4. We see a couple of things. First of all, I notice that this is kind of put it in a weird order. Let's rearrange it so it's something that we can recognize, which is 4 negative cosine, or negative 4 cosine 2x plus 3. What this does is it puts it in the order that we're normally seeing. So we see that this amplitude is going to be the absolute value of negative 4. And the midline here is y equals 3. So for my maximum value, we're going to take our midline of 3 and add the amplitude as 4, 7. And the minimum value, take your midline and subtract the amplitude, which is negative 1. For the period, I know this is b equals 2, so that's going to be 2 pi divided by 2, which is pi. And the frequency is going to be the reciprocal of that, 1 over pi. So remember, cosine typically looks like this, where we see a full cycle within 2 pi, and it starts at a maximum. Well, this time we see a couple of things. We also notice that this is a negative, so this is going to be a flip over the x-axis. So let's go ahead and graph our midline. We know our midline is y equals 3. So here's our y equals 3 midline. Our maximum's at 7, so we're going to go up. Here's 4, 5, 6, 7 is going to be up here, kind of off the graph. And our minimum value is at negative 1. So there's our range of where our graph is going to exist. I also know the period is only pi, so instead of ending at 2 pi, we're going to be ending at pi. So it's going to go faster. And instead of starting at a peak, we will be starting at the bottom. So let's start at the bottom, and then we're going to be ending at pi, so we know it's going to repeat there. We know half of the way it'll be at those peaks. And so here we go. We have our full cycle of pi flipped over the x-axis with the midline shifted up to 3 and half the period. So then we're going to continue this pattern. Make sure that we don't have zigzags. We want nice rounded curves. And there it is. All right, I'll see you in class next time.